when you're looking at, today we're going to go over position time graphs and how to graph them and what we can get from them. The first thing to note is when you're looking at how things are listed in physics, the first thing listed is always the y-axis. So in this case, if I'm doing a position time graph, position is going to go on the y-axis, the time is going to go on the x-axis. This could be our displacement or our distance. The two main things that we can see from this is if we can find the slope, we can find out how fast something's going, the velocity or the speed. And if we have a curved line as opposed to a straight line, that means that we have a changing speed, which is going to be acceleration. So here I have three graphs. One, I'm going to show you what it looks like if something is speeding up. One, if something's moving at a constant velocity. And one, if something is slowing down. So if something is speeding up and the slope tells me what the speed is, I should expect my slope to get steeper and steeper. So I'm going to start with almost a horizontal line and I'm going to curve it as it goes up. And at each given point, I'll know what the speed is, and that's a steeper and steeper slope. You can do the same thing, not starting at 0, 0. My slope is going to be 0, and then it's going to get steeper and steeper as I go down. Something with constant velocity. That means that the slope has to be the same everywhere. So that is going to be a line like this. Everywhere on that line, no matter what 2 points I take, they're going to have the same slope there as the same speed or velocity. It could also not have to start at that value. I could start at 0.6 meters instead. That would also have a constant velocity. Something that's slowing down as opposed to something that's speeding up that's going to get steeper and steeper, this one's slope should be less steep. So I'm going to start with something that has a steep slope, and then it's going to level off. And again, it doesn't have to start at 0, 0. Another example would be a line like that. That starts with a steep slope, which would mean it's going faster, and it slows over time. All right, so I'm going to go through an example with you guys. A runner travels 50 meters in 10 seconds. He then speeds up to travel 25 meters in the next 10 seconds. He rests for 10 seconds. He then turns around and jogs back to his starting position in 30 seconds. What would the position time graph look like? The first thing I want to do is look at the ordered pairs I have. So I'm going to make a little chart, and I'm going to have time is my x value, and position is my y. And I'm going to start at 0, 0. So at 0 seconds, he's located at 0 meters. At 10 seconds, he is now at 50 meters. In the next 10 seconds, he goes 75 additional. So I have to add 10 seconds to my time total. So now I'm going to be at 20 seconds, and I have to add 75 meters to this. Now I'm at 125. He's going to stay in the same place for 10 seconds. That's going to take us to 30. This will still be 125. And then for the last 30 seconds, so from 30 to 60 seconds, he's going to go back to 0. All right, so this was made already for us. So we didn't have to do the increments for the graphing. We'll do that in the next example. So I'm going to graph this. And I'm going to go 0, 0 is my first point. My next point would be 10, 50. And I'm going going to connect this with a straight line because I'm saying he's going this speed for the whole time. The best I can. Now what I'm saying is, from this graph, I can get what that speed is. And how would I do that? I'm going to find the slope. So the slope, if you remember, is y2 minus y1 over x2 minus x1. And so I'm going to have 50 minus 0 meters over 10 minus 0 seconds. And that's going to give me 5 meters per second. So everywhere on this line, this is going to be 5 meters per second. So for my red segment, I have 5 meters per second. For the next segment, he speeds up and he went an additional 75 meters in 10 seconds. So I'm going to have to add 75 to 50 and 10 to 10. So I'm going to end up at 20, 125. And I'm going to connect this with a line. So it's a little bit steeper. That's our second one. Now, if I want to find out how fast he is in this segment, again, I need to find the slope. And so I'm going to do y2, which is 125, minus 50 over 20 minus 10. And this is going to give me 7.5 meters per second. He then rested for 10 seconds. So that's going to take me from 20, 125 to 30, 125. And you see that the slope of that line would be 0. And so that means that for that segment, his speed is 0 meters per second. Finally, he's going to return back to the start in an additional 30 seconds. So that's going to take me to 60, 0, and I'll try to connect this with a line. How good I am at drawing a straight line. All right, now I can find what the speed is in this one. Now this is a little bit tricky because speeds can't be negative. So I'm going to get a negative slope, but I'm going to take the positive value because speeds are always absolute values. Velocities can be negative, speeds can't. So in this case, I'm going to have 0 minus 125 meters over 60 minus 30 seconds. And this is going to give me negative 4 1/6 meters per second, but I'm going to take the positive. So how far did he go? What's the total distance? He went 50 meters, then 75 meters, then he stayed at rest, and then he went 125 meters. So that would be 250 meters. His displacement would take into account the direction. So he went 50 meters positive, he went 75 meters positive. 0 is just 0, but then he went backwards 125. So that would give him a displacement of 0 meters. Average speed, that's just going to be the distance over time. So in this case, we said he went 250 meters over 60 seconds. So this is just 4 1/6. Average velocity is displacement over time. And his displacement was 0. So 0 divided by 60 is just going to give us 0 meters per second. Next time.